to this Zoom video presentation of Senior Design Project, which you will hear soon. I would like to specifically thank our sponsor, Vodafone, and Haley Kirk, the Liaison, who said may make it, and she made it. That's great. So, Chris, now you can go ahead and play the two videos. Let's first start with the Dean's welcome message.
Hi everyone, I'm Emily Allen, Dean of the College of Engineering, Computer Science and Technology at Cal State LA, and I'm here to welcome you to our virtual Capstone Expo 2020. That's the Expo that's virtual, not the capstone projects. In fact, our student teams have been working on their projects since our kickoff in August 2019. That seems like a long time ago now, as the COVID-19 pandemic has forced us into physically distant but socially cohesive modes of operation. We have over 100 project presentations to share live with you over Zoom connections. We are very proud of our excellent senior design program, as it rivals programs nationwide in meeting curricular requirements for design. Engineering design is an iterative, creative, problem-solving process in which science, mathematics, and engineering and computing principles are applied to convert resources into solutions. It has a direct and vital impact on the quality of life for all people. With these stakes in mind, our students have been working hard all year long, and especially these past few months, to finish their projects, and these presentations represent the culminating efforts for their degree programs. We deeply appreciate our project sponsors and industry liaisons, our faculty advisors, and the teams that manage and provide instruction for these capstone courses, including Mike Thorburn and Chris Bachman, John Shamma, Howard Lum, Jason Song, and Rupa Purasengi, Paul Liu, Elaine Kang, Jungshu Lim, and Raj Pumula, as well as our staff members, Hasmeek Simon and Evelyn Lee. Now, on with the shows, and I'll see you online.
Hi, everybody. I'm Mike Thorburn, and on behalf of the Cal State University, Los Angeles, and the College of Engineering, Computer Science and Technology, I want to welcome you to the 2020 Engineering, Computer Science and Technology Capstone Senior Design Expo. This year, it's a truly unique experience for us and for you, as the Expo will be done live via Zoom. Additionally, sessions will be recorded for those not able to participate in the live event. The students have all worked especially hard to make this event happen and to ensure the audience is able to participate from a safe social distance. Between mechanical engineering, electrical engineering, computer science, civil engineering, and technology, we have about 100 presentations scheduled over a period of about 2 weeks. I encourage you to participate constructively in as many as you can. Your feedback is critically important to the students. As you're watching this video, you must already know about our webpage. If you take time to go through it, you will find detail about all of the presentations and projects. Cal State LA is protecting the event from mischief by using passwords, but if you request access, we'll happily send it to you. The students have been working on their projects since August of 2019. Obviously, the COVID-19 epidemic was a huge disruption over the last month and a half, and it's been hard for everybody. I'm proud to say our Cal State LA Engineering, Computer Science, and Technology students, just as they have always done, have shown great persistence to overcome the obstacles confronting them and have made a tremendous effort to wrap up their projects and present them to you now. On behalf of the university and on behalf of these terrific students, I welcome you to Expo 2020.
Good afternoon, everyone. Before we start, I would like to thank Vodafone, our sponsor, and Dr. Navid Amini, our faculty advisor, for letting us be part of an extraordinary project and guiding us in the right direction. Again, thank you for joining us virtually here today during these harsh times. We hope you enjoy our presentation and hope you continue to be safe. Let us begin. For a second, imagine that your side of you was diminished by almost 50%. Half your world is lost. Your loved ones, special moments, extraordinary landscapes, and texts all become omitted from you. Hello, I'm Chris, and we can't wait to show you guys the project we've been working on with regaining the field of view for hemianopia patients through software. So what is hemianopia and what causes it? Hemianopia, also by the name of hemianopsia, is a byproduct of a stroke or brain injury. An example, when vision on the right-hand side has been affected, it means that the damage has occurred in the pathways carrying visual information to the left side of the brain, and vice versa. For example, if I had vision loss of a right homonymous hemianopia patient, I probably would not be able to see half of my MacBook if it were right in front of me, like the image shown on the right side. Hemianopia affects plenty of daily life routines, like shopping, driving, running, but most important of all, it affects the simple necessary routines like reading, walking, and eating. It's a burden living with vision loss. Hemianopia is only one of many vision loss conditions. There's also glaucoma patients and countless more. All vision loss conditions disrupt the field of view in unique and unpleasing ways. Vision loss patients currently depend and rely on prism glasses as an optical aid. They are unique in the way they work with bending light. They are proven to be effective. But how effective are these 13th century, $2,000 prism glasses in reality? To discuss prism glasses is Michael.
In the past, prism correction has offered aid to those suffering from hemianopia, along with other medical vision loss conditions such as double vision. Prisms bend light. As an optical element, they can extend field of view when adhered to eyewear lenses. Prism placement is directly in the field of view on the lenses, and so it leads us to ask, does it help or does it interfere? Corrective prisms refract light before entering the eye. This bending of light allows for an extended field of view through the prism, but unfortunately results in an apical scotoma, or a loss of field of view. Image A on the left highlights this vision loss due to apical scotoma in gray. An object in the foreground here, in this gray area, here a cat, is masked by the other corrected object, above it a fish. Image B shows an image captured by a camera with a corrective prism placed on the bottom left of the camera lens. We can clearly see an extension in the field of view. The lampposts and the street are brought within field of view focus. Where we gain this extension though, we lose the lower half of a man. It can be a bit confusing, and so we see how prism correction has its limitations. And never mind the fact that they literally obscure the field of view. At $2,000, this is by no means a practical solution. With that in mind, our goal becomes clearer. Perhaps a modern solution. The evolution of digital cameras from standalone to built-in and the advancement of wearable technology offers a new approach. Intersecting these advancements, a digital heads-up display with form factor or size and weight similar to that of a prescription eyewear lenses provides new and exciting tools to visual aid. We can eliminate the previous apical scotoma entirely. We cut the previous cost by more than 50%, and it allows for continued development in the future. It's time to get rid of overpriced and outdated prism glasses and go with modern and more affordable smart glasses. To talk more about the hardware component of our project, we have Nerses.
Thank you, Michael. For this project, we're provided with the M100 smart glasses by a company named Vuzix. There were three main reasons for choosing the M100s. Firstly, the M100s are the more affordable smart glasses currently available in the market. Second, the display of the M100s is not transparent. This makes it ideal for our project compared, for example, to Google smart glasses, which have a transparent display. And third, all Vuzix smart glasses run on Android. This makes it developing and maintaining on them much easier. However, while working with the M100s, we do have a big roadblock. The old age, the Android API limitation, and the discontinued official supports makes it quite challenging to develop any further. But before we get to that, let's take a look at what we were able to accomplish. As you can see in this visual representation, we're adding about 25 degrees of lost view back into the person's vision using the built-in camera of the Vuzix. 25 degrees is a lot that is being added back. Just to put this in perspective, this makes it possible for patients to do about 90% of the daily tasks that they were very difficult or impossible to do without any visual aid. This is a big accomplishment and we're very proud of it. With this in mind, I introduce you Ray.
Thank you, Nerses. So what exactly was our idea? Our idea has been to develop a heads-up display application that will not obstruct the field of view, like the Prism glasses. Our goal was to provide a simple user interface while still providing aid. We knew how difficult implementing something like this would be, but we had to do it just right. Our main focus was to develop an app that was intuitive and easy to use. This would essentially give our users full control. I know you guys are eager to see what we have been developing these last couple of months, but seeking a proper solution to this problem was not easy, but we gave it our all. Without further ado, I proudly introduce BlindSpot, a modern optical aid.
As you can see, BlindSpot manipulates the image in real time, giving the user room for image configuration at any given moment. People with left hemianopia would not be able to see the tree on the right side with their left eye. But by grabbing the image furthest to the right, the tree in our case, and shifting it all the way to the left, the user will now be able to see the tree with their left eye. And this is all happening live. We have also added a nice looking compass to help users navigate easier.
Just like Nerses showed, you can see the two images on the right, each depicting different angles. We added two elegant transparent buttons for functionality while not obstructing the user's field of view. This simplistic design will allow users to dynamically adjust their image accordingly, allowing them to move the image to the right or the left. We also added a beautiful compass that labels the direction where the user is facing. But in order to accomplish no lag from the system while using the camera and modifying the image view, we implemented a buffer for the image view. Meaning, BlindSpot is constantly grabbing the image, displaying it, and releasing the image in a matter of milliseconds. This will allow for more memory to be freed up. It would also alleviate the CPU from getting exhausted from too many calculations if we analyze every image frame. The software that we're using is the Android SDK. This software development kit is rich in libraries, and it's a very popular OS. But next to talk about the fine-tuning of BlindSpot, I present Leo.
Despite what we achieved with BlindSpot, we want to make further improvements to it. This is why we want to get feedback from both optometrists and patients, so they can accurately tell us just how effective BlindSpot is as a visual aid. From the feedback they provide, we can not only improve the user interface, but we can improve BlindSpot's overall effectiveness as a visual aid. Here's Ray.
Just like Leo was saying, in order to fully obtain accurate results from BlindSpot, we're introducing GyroSense. This add-on application will show patients' head movement in an Android smartphone. With the help of an MMR sensor, GyroSense is able to accurately obtain head movement for testing purposes with BlindSpot. This will allow doctors to observe accurately field of view gained by hemianopia patients. The data and head movement will be all in real time. When the patient's head moves, the rendered image will follow.
In this GyroSense demo, my colleague displays the sensitivity of the MMR sensor. As soon as he starts tilting his head, we see the green triggers go away. These green triggers will go away when there is more than 5 degrees of movement. We also provide entries for doctors to adjust the degree sensitivity. In addition to the green triggers, we have added a 3D head model rendered using the OpenGL ES graphics library to give real-time feedback to movements. This real-time data will help doctors test the accuracy of our smart glasses app, BlindSpot. In hopes that this testing goes well, we want to be able to help other types of vision loss. To talk more about this, I bring back Leo.
Just like Michael mentioned, we don't just want to stop at homonymous hemianopia. We want to implement functionality for other types of hemianopia that are uncommon. One type of vision loss we have talked about is glaucoma. And although we have been testing BlindSpot on the Vuzix smart glasses, we want to make BlindSpot a multi-platform app. This allows more people suffering from vision loss an opportunity to not only improve their lives, but change it. And they are not going to be tied down to a specific platform.
We have also been experimenting with the idea of attaching a third-party camera to the smart glasses that will allow us to supplement extra field of view. This is because the main camera, the main built-in camera of the M100s is fixed to the frame. The external camera will be adjustable, allowing us to customize the device for individual patients for their specific needs. However, for this idea to be possible, an upgrade in the hardware for future is necessary for development. Obtaining the newer M300 version of smart glasses will give us that option. However, it will give us much more. For example, firstly, the M300s run on Android 6, making all the libraries that are currently inaccessible to us accessible. Second, the AR capabilities of M300 make it possible to integrate object detection and machine learning into the application. Third and finally, the USB on-the-go support or OTG support makes it possible to attach third-party accessories to the device itself. This could be a power bank or in our case, a third-party camera. Now let's take a side-by-side look and see how much more we can accomplish with an external camera. On the left, you can see what we are achieving right now, the 25 degrees with a built-in camera. And as mentioned above, because of the shape of the Vuzix glasses, we are unable to rotate the camera itself as it is fixed, therefore limiting the amount of view that can be added. However, on the right side, you can see that we're adding the external adjustable camera that will give us complete freedom in getting the necessary view. And again, this is only made possible because of the OTG support that the newer glasses have.
Over 1.5 million people in the US alone are hemianopia patients, and worldwide, over 300 million people have a form of vision loss. We hope our program is one of many projects that will help not only hemianopia patients, but other vision loss patients as well. Although there are optical aids in the market, our team believes that BlindSpot can be a more practical alternative while being more effective in today's modern age. Thank you for listening to our presentation. We will now be taking questions.
Hello, anyone have any questions?
So I just unmuted myself. Thank you, everyone. This presentation was almost perfect. So I would like to start asking you some questions. The first question is, what is the cost of your product? So you mentioned that the cost of prism glasses, since they need customization, is $2,000. What is the cost of your product with Vuzix M100?
You want to go ahead and answer that, Nerses, or?
Yeah, well, as mentioned, the prism glasses are about $2,000 currently, And the M100s, last check, they were around $1,000, and sometimes it can be even found with a little less. However, because of the discontinued support, the newer versions are probably going to start getting cheaper. So it's basically cuts the price in half what we currently have with the prism glasses.
Thank you. And the second question is, what is the battery lifetime of your BlindSpot application running on Vuzix M100?
Vuzix M100's BlindSpot applications runs about half an hour to an hour, but that's just because of the old hardware, and future development and better hardware will not be a problem, an issue in the future.
And what happens toward the end of the battery lifetime? Is there any fading or slowness or frames not being displayed in the correct order, or there is no fading at the end?
No, so there's no lag, and like one of my colleagues had mentioned in one of the slides, there's a continuous buffer going on the application, and it releases each frame as it goes on, so we're able to just keep going, and the app just keeps going as long as there's battery.
Great. And for the testing app, which runs on an Android phone, and the data comes from a motion sensor. On that application, you said that the user could input the degree of sensitivity. Is that right now, that feature, is that incorporated in the app, or it's something that you want to add later?
No, that's actually already incorporated in the app. 5 degrees is just the standard that we set, but whoever is utilizing the app can change that at any given time.
There might be just a small bug because of the rotation. The tilt works perfect, but with the rotation, because of the range has to be between negative and positive, because it goes around 300 degrees. There currently might be a bug when it crosses the cut between 360 and becomes 0. But that
Right.
should be able to fix it.
So if I am the user of this app and I don't know anything about coding and computer science, can I just change 5 degrees to 3 degrees and go from there? Or I need to hard code it in the application, the code?
No, it's all shown in the UI. All you have to do if the application is running, press stop, and it even gives you guides you where to put the minimum and maximum. You put the numbers, you start the application again, and it works with the given parameters. So anyone with no knowledge of coding should be able to use it.
Right, because on the interface, I don't see any button.
The T and the H are the buttons on the squares.
You mean to update the angles?
To update the sensitivity, the threshold of
degree.
sensitivity.
So
when you click start it already starts updated. It checks and then starts.
No, I think
it
he's
prompts the user.
So start, what it does, it starts the sensor, and then it starts gathering data. And then we get, next to tilt, we'll get a degree value. And on min, where it says min has to be higher than 90, negative 90, that's the minimum input of degrees, and then the max is another one. And so you can put the 5 degrees or 10 degrees on the max there, and then just hit that T button square, and it'll change the sensitivity. And you don't even have to stop the application. You can actually, the sensor, you can just, while the sensor is gathering data and displaying it, you can do that. You don't even have to stop it.
Okay, great. And my last question is, you said OTG support for the audience. What do you mean by that?
OTG is a thing that new USBs have. It's called on the go. This basically makes it possible. So instead of just traveling, instead of just moving power in there to charge the device, you can attach devices that move data between them. So let's say like an external camera or like maybe an external sensor. And we did check with the company and they did confirm that the newer versions do have that support. So you should be able with the USB port that the device has to connect other devices to it to transfer data between. That is not possible with the M100. Currently, the M100 only transfers power with the port and charges the battery. And the only means of transferring data currently is Wi-Fi or Bluetooth. So we will not be able to attach a camera with Wi-Fi without any lag, or it's not possible. We have to get the upgrade.
All right, thank you. So I have no more questions. Let's see if there is any question from the audience.
And Chris, how much time we have before the Zoom ends? We still have like 5-7 minutes.
We have
right?
7 minutes, I believe.
We have 8 minutes. Yeah.
Yeah.
Okay.
So let's just wait for 10 seconds, see if there is any other questions. And if not, we will wrap it up. All right. This was a great presentation. I would like to thank you again. And also, I would like to thank all the participants. I would like to thank our sponsor, Vodafone, and our liaison, Haley Kirk, who made it today. We would like to ask for Vodafone's continued support of our senior design projects. So with that, I would like to emphasize that we are not finished yet. So you are still working on your final report and the paper, which is equally important to this presentation to Vodafone. So I will be in touch with you guys in the next week or so that we could logistically finish this project. But as far as presentation goes, you're done and you did an excellent job. Is there any questions from the group members, Chris, Nerses, and everybody else?
No, we just would like to thank you for guiding us for the whole year since August. It's been a pleasure.
My pleasure. So I hope you have a good day, and I will be in touch with you, and I will, Chris, please place the recording in our shared Dropbox folder just for reference, and then I need to share it with other folks at Vodafone and UCLA.
Perfect. Well done.
Thank you so much.
Thank you.
Thank you, everyone.
Thanks everyone
Thank you.
for participating.
Thank you.
Take care.
Yeah, stay safe.